So the title on this is wrong because I changed it after I printed it, so ignore that part. But we're going to be talking about forms of a quadratic equation. So this is not really part of 5.2.1. It's kind of assumed knowledge, which is not awesome. So we wanted to be sure we talked about it. So in section 5.1, we made connections between graphs, tables, and situations and equations for quadratic functions. Today, we're going to explore the relationships between the different forms of quadratic equations and learn a new form known as graphing form. So let's see what that means and what's going on. So the first thing I see is I look at this graph and I'm going to notice some important things. So I've got my table, I can notice things from the table. I've got my graph and I can notice things from my graph. So it's whichever is easier for me to notice from. So I notice the y-intercept. I can also see that here on the graph that those match. And so I'd write y-intercept is 0, 3. I notice the x-intercepts. And here they are right there. And there's the other one. Okay, so those are x-intercepts. And so I'll write them down up here as well. And so -3, 0, and -1, 0. I can also see both of those on my graph. I'm going to go ahead and start with factored form because I only need my x-intercepts and another point to get factored form done correctly. So let's actually move this down just a tad. There we go. So I've got my two x-intercepts. I'm going to do factored form from the x-intercepts. And so I know that that must be, I'm going to go ahead and write factored form over here, which we kind of went over. I think it was in class today, but it might not have been. Factored form is a parentheses x plus or minus a number, and x plus or minus another number, just assuming they're different. But basically, you have your two factors where -m and -n are the x-intercepts. Okay, so my x-intercepts are -3 and -1, and so my equation will be x plus 3 and x plus 1. And then I need to make sure that a, so I've got y equals, and a is here. I need to check and see what a is. You want to check the y-intercept to see if it's 1, or just to check that you have the right a value. Doesn't mean that it's 1, we're just going to check. So what we're going to do is we're going to plug in the y-intercept. That means when I put in 0, out comes 3. So I'm checking with the y-intercept. I'll go ahead and do that here in blue. And so I have y equals a times, I put in 0, so 3. I put in 1, 0 again, and I get 1. And so I get a times 3. So I'm supposed to be getting 3. I'm supposed to get 3, and I did. So a has to be 1 so that works out. So a equals 1. So I should have put over here y is 3. So I'm replacing y with 3 and x with 0. And so a is 1. Okay? So that means I can go back and write, let's write it again, y equals x plus 3 and x plus 1. So that's factored form. Now standard form, if we don't recall, I will do in a different color. Let's use the star color. Standard form is y equals, sorry, and the factored form should have y equals in front. Standard form is a x squared plus bx plus c, where a, b, and c are the leading arcs numbers. And so what I can do is I can take factored form and turn it into standard form. I actually don't know how to look at the graph and write standard form. There are a couple I can do, like if it's just been shifted up and down. I can do that without doing anything else. But this one's been moved all over the place. So, and so factored form is, and the only thing I know is that c is 0, c is 3. So when I plug in 0, I'm supposed to get 3. Well, that's not very helpful. I don't know a and I don't know b, and oh my gosh. So What I can do though is I can take factored form and multiply it to turn it into standard form. So y equals x squared, x times x, plus x times 1, plus 3x, 3 times x, plus 3 times 1, which is 3, and so y equals x squared plus 4x plus 3. And so that's standard form. Okay, exciting. Now, the one point that we didn't use that's one of the most important points on this graph, and we haven't used it, is the vertex. So graphing form is also called vertex form, so it's graphing form or vertex form. I like graphing form as a name better because then we can use it for every type of function, and there's a lot, and not all of them can be written in. Not every function has a vertex, but they all can have a graphing form. So it's also known as vertex form, but we're going to call it graphing form. So my vertex is right there at -2, -1. I can see it on my table because it's notice that the other numbers kind of go around it. So 0, 0, 3, 3, 8, 8. That's how I can find it on my table, is that's where the symmetry seems to be emanating from. It's not the greatest or most reliable method, but it works. So there's my vertex. Now this is very interesting. So graphing form, let me write it over here like I did with everything else. So graphing form is y equals a parentheses x minus h squared plus k, where h and k is the vertex. Okay, so h comma k is the vertex. Notice that the h coordinate is being subtracted from x, and the k is being added, but if I moved k over to be with y, it would be y minus k. So if it's with the variable it belongs to, so let k is the y coordinate, be like that. So anyway, if I know my vertex, y equals a parentheses x minus -2 plus -1. And some of you have used this because you found it somewhere online. You were looking up how to graph equations, and you found this, and so you've been using it. And that's great. I don't have a problem with that, but now we're going to learn about it together. So y equals, again, a parentheses x plus 2. Oh, wait, I forgot to square that. Squared minus 1. This is very important. Vertex form can be obtained from standard form very easily, but it's a little trickier to do from here. But anyway, a we've already discovered is 1, but we would plug in the y-intercept to verify that if we had started here. So there's my equation in factored form, graphing form. And if I switch back to vertex form, that's because that's how I was trained up. That's what I called it when I was learning it, so it's hard for me to go away from those words. Okay. So those are the 3 forms. So that is the goal of our work today, is there are 3 other equations, is to take them and change them. The solutions from part A this should not be here. I will make sure this is not on your paper when I publish that. I'll make sure that's not there. So that's the basic idea. So let's go ahead and try number 2 together, and I will leave you to do 3 and 4, and this shouldn't be here either. Wow. I'll leave you to do the other 2 on your own. Okay, with the answers, and we are doing this together. So let's go ahead and try number 2. All right. So when I look at this, I'm going to check for the vertex. There's the vertex. Vertex is green. So y-intercept first. Y-intercept is 4, 0. I don't want to circle that. So I just am going to notice everything. 0, 4. X-intercept. Looking for 0 here. So that's -2, 0. Vertex is the middle point. So I'm looking at the numbers as they go around. They seem to go around. Oh, they go around the 0. So this is the vertex. So my vertex, which is easier to see from the graph, is also my x-intercept. You'll notice that we only have one x-intercept. Whenever we only have one x-intercept, it has to be the vertex if it is a function. So whenever we only have one x-intercept, it has to be the vertex if it is a function, period. Otherwise, there will be two x-intercepts. Okay, so let's do vertex for our new form, graphing form first. So we have for graphing form, y equals a parentheses x minus the x coordinate, which is a negative number, so I'm going to write +2, squared, plus 0, the y coordinate. I'm going to check to see what a is by plugging in my y-intercept. So I know I'm supposed to get, when I plug in 0, I'm supposed to get 4. So yes, a is 1. And so once I know what a is, I write my graphing form equation, y equals 1, x squared, x plus 2 squared, plus 0. Let me write that. There you go. What's cool about this is you can tell your vertex by looking at this form, which is awesome. Okay, now let's do factored form. And this is where factored form is a little weird. There's only one x-intercept. So how do I get two factors? Well, when there's only one x-intercept, it's because it showed up twice. It's called a multiplicity. That is a word that will matter a lot. It's a multiplicity of 2. When an intercept is there once, it's a little funky, and I don't want to get into what it does because we don't need it right now. But it basically is there twice. And so factored form and vertex form in this problem are the same because my factors are, I have two of them that are the same. If you want to kind of maybe write it down this way, makes a little more sense. That's why I got the same answer factored into two that were identical. Standard form, we're going to just take and expand that, and we, oh, let me put, I like this one better, so I will put this one in a box. But it's easier to use this one to get back here. Y equals square on the left, square on the right. 2 times 2 is 4. And 2x and 2x, which is y equals x squared plus 4x plus 4. And I check my y-intercept is 4, like it's supposed to be, because c is 4, yay. And so that's the idea. Okay? So I think graphing and factor form are the two easiest to start with. I never start with standard form. And again, I only know how to do standard form first if my vertex is on my y-axis. If my vertex is my y-intercept, I can start with standard form. Otherwise, I cannot. All right. So go ahead and see what you can do with number 3. Pick a form. Actually, find everything. Let's find everything. So we need to find our y-intercept, our x-intercepts, our vertex. And maybe notice something else. So y-intercept first. Yep, I agree. It is -2. X-intercepts. Oh, they're fractions. Do your best guess. -0.5-ish, comma 0, and -3.5. These are not accurate. They're my guess. Vertex. There you go. -2, comma 2. And so what I can see from my picture is that between, so like at -1, these are positive numbers. I can see my vertex here. I can see my y-intercept here. My x-intercepts are not on my table because they're decimals, but they occur between -3 and 4, and between -3 and -1 and 0. And so I'm going to start with vertex form, graphing form. Y equals ax plus 2 squared plus 2 on the outside. Then we need to figure out what a is. So we do that by plugging in the y-intercept, which would give me 4 equals, excuse me, -2 equals I'm going to move this 2 over with this one. So I get -4 equals a times 4, which makes a equal -1. So graphing form, y equals -1, x squared plus 2, quantity squared plus 2. Okay. In standard form, I'll go from here. I get y equals okay. And then I would try to go to factor form because they were fractions and decimals, and I can't because this does not factor. The best I can do and that's not really factoring it, is it? So that's the best I can do. Go further. Okay. You're going to do number 4 on your own. Go ahead and pause the video, go through all of number 4, do the very best you can, and we will talk about it in just a minute. All right, so we have standard form. I started with graphing form. I noticed that there was a y-intercept of 6. There were no x-intercepts. The vertex was at -2, 2, which is the same vertex as the previous problem. So I started with graphing form. X plus 2 quantity squared plus 2. I did verify by the plugging in I would get 6 out for my y-intercept. I didn't write it. I did do it. Since there are no x-intercepts, the factor form does not exist, as what D and E stands for is does not exist. And that is because there are no x-intercepts. Factored form, standard form. I just expanded and combined. And that's it. Have a great day. I will see you guys soon.